Okay, number 73 is asking you, and the directions just say calculate the integral. Doesn't really tell you how. So they're asking us to come up with the definite integral from -1 to 1 of the absolute value of x cubed, taken with respect to x. And this problem right here has two little quirks to it that make it kind of challenging. The first of which is the presence of the absolute value. And let me tell you that without that absolute value, this would have been a really easy problem. Here's why. X cubed, again, I'm graphing it without the absolute value, looks like this on the right, and then it looks like this on the left. It's an odd function, everybody. It's got symmetry with respect to the origin. So if I was asking you guys to evaluate here the integral from -1 to +1, you'd have one region right here below the x-axis and another region right here above the x-axis, and I'm hoping everybody realizes that integral would be 0 because those two regions right there just cancel each other out. Region, I guess this is region 2 here being above, region 1 here being below, but they are congruent in size. However, that's not exactly what's happening right here. They're asking you to evaluate the absolute value of x cubed. So, the first thing that's tricky about this problem is knowing how to graph this function. Now, you could use your calculator, but you guys, I want you to learn this trick right here. For graphing a function with an absolute value, think about what it would normally look like, and maybe just draw that with a dotted line here. So this is more or less what we just had drawn. And now I want to remind you guys that absolute value has no impact on the value of a function if it was already positive. And where was this thing already going to have a positive y value? Over here in the first quadrant. So, putting an absolute value there doesn't change at all the graph that we thought we had. However, what absolute value does do is it takes any negative value and turns it positive. Now, where was this graph going to have a negative y value? Right here in the third quadrant. So every negative y value that you had here is now going to get reflected up into the second quadrant, and its y value is now going to be positive. So we're going to get a graph here that looks like this. So what we have now, guys, in blue here is the graph of y equals the absolute value of x cubed, which looks a lot like the graph of y equals x squared. I could understand why you guys would think that, but that's not exactly the case. So, first challenge, that's the graph of y equals the absolute value of x cubed. Second challenge now is we're trying to figure out the net or signed area here between -1, which does this, and +1, which does this. Now, here's what I'm hoping you guys realize. Those two values we just came up with, or those two regions in red, are congruent. They're the same. So what I can do now, guys, is just focus on, let me shift colors on you right here, is just focus on this region right here, and then just double your answer. So this integral is going to be 2 times the integral of, and let's just think about this region right here. It's an area, a region that starts at 0, right here, ends at 1, right here, and that graph is just the same as x cubed without the absolute value taken with respect to x. So that's how we're going to answer this question. We're just finding the area of half of it and then doubling that result. Now, do we know how to do this? Sort of. If we go back to these properties here that were given to you in your notes, in fact, let me take all of these and let me slide them all down just a little bit. At some point, we probably figured out the joke. The integral from 0 to b of x cubed taken with respect to x. Well, guys, if you just read this coming up the ladder, here's b squared, b cubed. This one is going to have b to the 4th. And the coefficient, 1/2, 1 cubed, now we're going to have a 1/4. So this is an idea. They're kind of asking you to make just a logical leap right here, but I'm going to tell you that one is right, and we'll talk more about that in section 5.3. So this integral then is just going to be a 1/4 b to the 4th. Now, the 2 out in front is still there. So now, here you go. This integral is a 1/4, and your b value is your upper limit of integration, which is 1 raised to the 4th power. So what do we have here now, guys? 1 to the 4th is 1. 1/4 of that is 1/4. And a 2 times 1/4 is going to give you an answer of 2/4 or 1/2. Okay, so it's a pretty small region right there, guys, but that's what we came up with for the area of this whole thing. And so that integral from -1 to 1 of the absolute value of x cubed is going to end up just being 1/2.